did.
Alright, so yesterday we did the first section of 1.2. Now we were just measuring using the little rulers that were provided. So today we're going to start right here. It's on the second page on the back. So yesterday I started to tell you about betweenness of points. So this just means that, let's draw a line right here. Let's draw a line. Carter, give me 3 points. A, B, and C. Okay. Betweenness of points means that if I have point A and point C, and then I put B in between them. Okay, so not in the middle. It doesn't have to be in the middle. It can be, but doesn't have to be in the middle. It's just somewhere in between. Is it true that AB plus BC equals what? This section plus this section, add them together, and it gives me AC. A third of a, what's your favorite candy? Anybody?
Twizzlers.
Okay, Twizzlers. I'm going with Twizzlers. It's a better example. Okay, Twizzler. This is a third of a Twizzler, and this is 2/3 of a Twizzler. How many does it make? One whole, right? What about Snickers? Do y'all like Snickers? Half of a Snickers plus the other half of a Snickers equals the whole Snickers, right? So if I take this part and add it to this part, I know the total length of this segment. So say this is 3 centimeters, and this is 4 centimeters. What's the whole length? 7. Okay, so that's just the mindset behind this. Now, there's another word, or another saying that I like better, besides betweenness of points. This is also called segment addition, postulate. You're adding segments, okay? Segment addition postulate. Now, in our first example, I'm going to make you do a little extra work. And I won't make you do it every time, but I want you to understand the part behind this. I don't want you to just add them together. So if we look at this one, here's segment RT. I know RS and I know ST, but I need to know the whole thing. Well, can't I just add them together? Yes, but I need you to know the mindset behind it. So I need you to write the formula. I'm not going to make you do it every time, just a couple to get you some practice. So the segment addition postulate for this segment is that segment RS plus segment ST equals what? RT. This part plus this part equals the whole. Okay? Well, now let's substitute in what we know. I know RS is 2.0 centimeters. So instead of writing RS, let's write what it is. It's 2 centimeters. And ST is 2.5 centimeters. So when I add them together, how many centimeters is RT? 4.5 what? Centimeters. Good job. Please circle or get in the habit of circling or boxing your answer. But underline, it's fine. Just something that makes it stick out. Here is why I made you do that extra work. You're not always just adding two numbers, okay? So let's write the formula, the segment addition postulate for this segment. Segment AB plus segment BC equals what?
AC.
AC. All right, let's substitute in. I know you can't really see this. It's 3/4. 3/4. So instead of writing AB, we're going to plug in 2 and 3/4. You don't have to write the unit every time right here. Just make sure it's in your answer. Okay. 2 and 3/4. Do I know BC? Nope. So leave it like it is. But I do know AC is 5 inches. Now, isn't this just a one-step equation? Okay, I know these two, I need to solve for BC, so how do I get this one to the other side? Subtract it, yeah. Good job. Okay, so those cancel. And I know that BC, don't you reach for that calculator. Think about it. Think about it. Come on, think about it. Let's round this up to 3, right? Let's round it up to 3. What's 5 minus 3? So there's 2 whole. And then I'm subtracting 3/4. How much is left? 1/4. Okay, now you can use your calculator if you want. I just wanted you to use your brain a little bit. Now, let's think about this without writing anything down. Miss Jenkins, I know that's 5. I know I can just subtract it. Okay, that's good. Okay, you can do that. You don't have to show me this every time. But we're going to start doing proofs. You have to write proofs in geometry. And you might need to show a little bit of work, okay? So, I know this is easy. There's an easier way. I'm making you do the long way. Just trust me. All right. You see these little dashes on 3? How many are there on each side? 2. Those dashes tell you if things are congruent. So if there's 2 dashes over here, and there's the same number of dashes over here, that means that both of these segments are the same. Well, if the whole is 6, and I know these are the same, so that means this point is the middle. It's the very middle, because these two are the same. So how much is each side? 3. So segment WX is equal to 3 centimeters. And I knew that because there were the same amount of dashes on each side. Yes? You could, but no, WX. I just wanted to find this segment because that's what it told me right here. Okay? Sorry, I didn't explain that part. All right. Y'all ready to have some fun? We really are going to have some fun as soon as we get done with these notes at the end of the page. Then we're for real, like, it's kind of cool. Okay? All right. So until then, let's draw our line. So we're talking about a line. So draw your line. Now your instructions tell you to find X and BC if B is between, so the order does matter in this case because it told you so. B is between C and D, which means C and D are on the outside. Now between this doesn't mean middle. It just means somewhere. Just means somewhere. So anywhere. There's B. Okay? Am I good? You good? So far. I just put B in the middle because it's between. Doesn't matter exactly where it's at. So now, number 1 is telling us these things. CB is 2x. Okay? So I know this part right here is 2x. From B to D is 4x. So from here to here is 4x. This is a typo. It's supposed to be CD. Sorry. So it told me each little piece, and then it told me CD is, the whole thing, is 12. This is where your formula comes in handy. Let's write it twice more. Let's write it 2 more times, and then I'll let you stop writing the formula, okay? Well, in this case, CB plus what? BD equals what? CD. Nice. Okay, substitute in what you know. Instead of writing CB, write 2x. Instead of writing BD, write 4x. And then CD is 12. Yes, and then solving, because they're on the same side of the equal sign, right? All right, solve for x. But you also have to find something else, don't you? What do the instructions say? I underlined it. X and BC. So we know BC is 2x. Well, do we know x? Yes. So instead of writing x, 2 times 2 is 4. So BC is equal to 4. Did they give us units? Nope. If that bothers you, you can put U in. If it doesn't bother you, just be unbothered. What does UN stand for? All right, let's do it again. Now, some of you could use the same line. I don't like to use the same line because I already wrote on that line. Okay? I like things to be semi-neat. So I'm going to draw my line again because I want to. It's the same line, same points, but I like to see exactly where I'm writing. Say 4x minus 9 is CB. BD is 3x plus 5. And the whole thing is 17. Now, I'll let you skip the formula. I'll let you skip it.
Ms. Jenkins?
Yes, ma'am.
Can you please send Reese Yarbrough to the attendance window for a minute?
Yes, ma'am.
Thank you.
You know where that's at, Reese? All right, so if I'm letting you skip the formula, don't you know that you have to add this little piece plus this little piece, set it equal to the whole. So you have 4x minus 9 plus 3x plus 5 equals 17. Okay, go ahead and solve. What was x? 3. What'd you get for BC? Still working? Or did you forget to do BC? It's 3. BC is 3. Alright, I want you to try number 3. These are different points. Okay, they're different. So you have to start with a new line. So try number 3. All right, so your equation should have been set up x plus 2x equals 2x plus 5, because your line was A, B, C. Okay, so I knew AB was x, and this was 2x, and then the whole thing was 2x plus 5. So from here, you just need to solve. So 1x plus 2x is 3x, and then 2x plus 5. Subtract 2. So we got that x is equal to 5. But you also needed to find AC. Well, AC is this right here. So plug in x. So now we have 2 times 5 is 10, plus 5 is 15. Okay? All right. Let's go on to the next part. We're going to practice this some more. Miss Smith, you can have this one. Let's go into the next part. And then these are our last two. And then we're going to actually make some constructions. Huh? I know. You'll see. All right, so we're talking about congruent segments. So this is a little bit different. We're determining congruent segments. Are segments congruent? So segments that have the same measure are called congruent segments. That means they have the same measure. So down here, congruence means they have the same measure and length, which those are basically the same thing. Their length is the same and their measure is the same. So there's a symbol that we use to show congruency. You've probably seen it before. It's that little squiggly, which isn't that a tilde? Is that a tilde? Tilde and then an equal sign. So all together, that means congruence. So in number 1, we have to tell if these two sides, these two segments, are congruent. Remember those dashes you saw at the top? We're going to use those a lot in geometry. So AB, what's the length, class? 5. And what's the length of DC? Are they the same? So let's practice putting 1 dash on each side. That means they're congruent. So if they have the same number of dashes, they're the same. Now, are the top two segments the same? Okay, well I can't put 1 dash because that means it's 5. But I can just go up a dash. So if I put 2 here, 2 dashes there, that means that it's congruent to the bottom. So let's just start practicing that. Well, AB is 5, CD is 5, so are these two congruent? Okay, so here's how you answer it. So this is your answer. Segment AB is congruent to segment CD. Now it's a segment, so the order can be opposite. You could put DC. You could have started with DC and then put AB. You could have swapped these. Okay? This is talking about congruence. This means congruent. Congruent. If you would have put no bar on top, if you put no bar and no tilde, you just have an equal sign, this is talking about the length, which they mean the same thing. They mean the same thing. But here, you would want to put like the measures in. Okay, so this means they're congruent. This means you're talking about the measures. It's the same thing, it's just a little bit different. If it says, are they congruent, then put this. Okay. All right, number 2. Don't get confused. These two both have one dash, right? That means they're the same. But that's not what I want to know. I want to know, is XY congruent to YZ? Well, what's our first step? I don't know. I don't even know what the length is. All I know is that these two are the same. And they have a variable. Make an equation. How? Equal to each other. Yes, they're equal to each other. They're the same. So let's set an equation to solve. So I know these are the same. So I'm just setting them equal to each other. And let's solve for x. Subtract 3x. Okay, this isn't my answer, right? All I did was solve for x. Now, let's plug this back in and see how long this actually is. So, it's 3. 3 times 3 is 9. 9 plus 5. Well, if that's 14, what's this side? Okay, still haven't answered my question. This is 9x divided by 2. I know it's kind of blurry. 9x divided by 2. So now let's plug in our x to yz to see what that is equal to. Well, 9 times 3 divided by 2. 9 times 3 is 27. Divided by 2 is 13.5. Well, what's our answer? Not congruent. It's not the same. So here's how you write that. Segment x, y. Remember how you write not equal? Kind of the same thing. Not congruent to yz. Alright, we're going to practice some more. But it's time to move on to the fun part of section 2. Now some helpers. Collate 1, 2, 3. Alright. This thing we're about to use is called a compass. It is very sharp. Do not touch anyone with it, not even yourself. I mean, like, don't poke yourself. Okay. Everybody one of this. Everybody one of this. Everybody one of this. So what we're about to learn, 4 more rulers. Oh my goodness. one more. How many more do you need? Okay, y'all just have to share with a partner. Okay? So if you don't have one, share with a partner. Oh, they have more rulers, just I think more running low on costs. Okay. Here we go. So your first blank is construction. So on this sheet, constructions are methods that create geometric figures without using a measuring tool. So here's what we need to do. We have segment PO. I need you to copy that segment exactly without using your ruler. There's a trick. You ready? All right, here's step one. If you're using a pen, I would move to a pencil for this part. Okay, here's step one. This will be on a test. You'll have to do this on a test, so make sure you're following with me. I don't want you to measure it. I just want you to use this ruler, and I want you to draw a line. Just make sure it's at least longer than that line you see. Okay, so I just drew a line. Okay, next. So we're using our ruler not to measure, but to just draw lines. Okay, take your compass. If you don't have one, you're going to share. Put the pointy dot, this pointy side, on P. And then use your compass and make it to where it touches exactly where O is. Okay? Now pick it up once you have what it is. Let your partner use it if you need it. Okay, go ahead and put a dot right here. Make it a little dot. So I have a dot. And this is P. Okay? Now, so if you were having to share, you put your pointy dot on P, and then just make sure it's equally lined up with O. Okay? Now, take it back over here. Put pointy side on P. Stand it up. And make a mark. Just a little arc. Wherever it crossed your line, that's your other point. So you just copied the segment without measuring. You just made a construction. Cesar, do you have a compass? Okay. Who doesn't have one? Oh, just you. Okay, let's try number 2. Same thing. Don't copy it exactly. Just draw a line. Go ahead and put your dot. Put a dot for C. So you have a starting point. I like to turn mine so I can see it. Put the pointy spot on C. Squeeze it in to where it's on D. Okay, then I'm going to come over here to the C, stand it up straight, and put an arc. So this was D. Pretty cool, huh? Okay, for our sake of time, we're going to skip the next 2. It's just the same thing. So you can practice those if you want extra practice on your test. But let's go to the back. So on the back, we have to bisect. So this blank is called bisector. Bisector. It's any line that cuts a segment in half. it cuts it in half. So we need to cut this line in half without measuring it and just dividing that by 2. So a bisector cuts it in half. It goes directly to its midpoint. You ready? Compass. Put the point over here, and then make your pencil a little bit more than halfway. So a little bit more than halfway. Stand it up straight. This time I want you to make a big arc. Make a big arc. Okay, when you're done with that, I just made like a half moon. Keep it the same distance. Go to the other side and do the same thing. Did your arcs collide? Good. Right here, do you see how these 2 points are right on top of each other? So where they collide, I put a dot. Now take your ruler and draw a line from one point to the other. Guess what you just found? The direct middle of that line without using a ruler. So this is the bisector. It's the line that cut the segment in half. That's your bisector. Okay, try number 2. So start on one end, make it a little bit larger than halfway. Make sure that it's standing up when you're drawing your arc. Make sure it's all the way up. Yes, okay. Hey, y'all pass this to DeAndre. Melody, pass that to DeAndre. Does it remind you of one of those fishies? That's what it reminds me of.
Reminds me like when you go fishing, like, right?
Yeah. All right. Awesome. Okay, I'm going to leave the extra 4 problems just for you to practice. You can come in here during 0 period and get a compass. We might have time during class. I can't promise. But this is your homework. I passed out an extra sheet that said 1.2 practice. Do you have it? Okay, your homework, 1 through 12, odd. 1 through 12, odd. If you talk to someone in first period and they said they're doing evens, they are. Okay? So your homework is 1 through 12, odd. First period is doing evens. Just leave your compass and rulers on your desk. Have a good day. I'll see you tomorrow.